Welcome to In 5 Minutes. Now let us quickly also understand how M2T will be extracted. So for that we will consider the second product modulator. Output of the second product modulator, I'll call it X2T. I will pass it through a low pass filter and my final output will be XOT. If you observe carefully, we are not giving cosine form of the carrier to the second product modulator. It is passed through a 90-degree phase shifter. The input to the second product modulator is sine 2 pi fct. So we are going to multiply sine form of the carrier with the same incoming multiplex signal. So let's see how my output of product modulator and the final output is going to look like. So the input to the second product modulator is sine 2 pi fct. This is my x2t output of product modulator and my final output is xo2t. So once again, I'll quickly write down S of t here. First, S of t was nothing but m1t into AC cos 2 pi fct plus m2t AC into sine 2 pi fct. Now x2t, which is output of the product modulator, is nothing but S of t, the incoming signal, the multiplex signal, multiplied by sine form of the carrier. We'll write down the final expression directly once again. I'll write it here. X2 of t is equal to, you can see first we will multiply sine with cos. So we'll get sine into cos with the same angle. So we will again use the formula of 2 sine theta cos theta. So that will give me half AC m1t sine of 2 theta, which will make it 4 pi fct plus, when I multiply sine with the second term, sine into sine will be sine squared theta, and I will use the relationship that sine squared theta is equal to 1 minus cos 2 theta by 2. So when we write down the expression, we will get half outside AC m2t. Inside the brackets, I'll have 1 minus cos of 4 pi fct. And now you can see that once I expand the brackets, it's really not required, considering that we have done the previous analysis in similar way. If you expand the brackets, you get the first term which is going to contain only m2t, and the second term will be m2t into cos 4 pi fct, which will correspond to the frequencies present around 2fc. The first term also has frequencies present around 2fc because it is sine 4 pi fct multiplied by m1t. So when you pass the signal through a low pass filter, my output of the low pass filter will only allow the frequencies up to 20 kilohertz to come at the output side, and hence the output will be half AC m2t. Alright, the sine 4 pi fct term and cos 4 pi fct term will be blocked by the low pass filter. So that becomes my second output, and you can see that we have got the second modulating signal back. So this simple analysis proves that it is very much possible to demodulate the multiplexed signal, and this is simply possible by multiplying the incoming signal with the corresponding forms of the carrier signal. To obtain m1t we need cosine form, to obtain m2t we need sine form, and this is done because m1t was modulating the cosine form of the carrier on the transmitter side and m2t was modulating sine form of the carrier on the transmitter side. So what is the advantage we get? If you carefully observe, if I draw the frequency spectrum of quadrature carrier multiplex system, if I draw the frequency spectrum, we are using only single carrier signal, not using two different carrier signals. So I may have the so let us say this is FC mark. We may have frequencies of the first modulated signal present up to, let's say these points are FC minus FM1 and this point is FC plus FM1, and we can have all the frequencies of the first modulated signal will be between FC minus FM1 to FC plus FM1. Now we can have the second modulated signal with the frequencies, let's say from FC minus FM2 up to FC plus FM2. So if you look at the total spread of the bandwidth, the total spread of the bandwidth is nothing but twice FM2, which we will anyways require to transmit the signal M2T. If you are transmitting M2T using amplitude modulation, the bandwidth required for the transmission or the bandwidth of the modulated waveform will be nothing but twice FM2. Now, in the same bandwidth of twice FM2, you are also able to fit in the signal which is containing the first modulating signal. You are able to fit in the frequency spectrum of the first modulated signal, which will otherwise require the bandwidth of twice FM1 separately for its own transmission. So, what is the advantage of quadrature carrier multiplexing? Is that we are saving bandwidth. We are transmitting two signals using one single carrier frequency, and hence we are saving bandwidth that we will otherwise require to transmit two signals independently. And why such type of multiplexing is possible? Because we are using the same carrier frequency but in two different forms, cosine and the sine forms of the carrier on the transmitter side, and we are again using cosine and sine forms of the carrier on the receiver side for demodulation.